Hi everyone. In this video, we will be looking at why is it that we can multiply along the branches to find the probability of a certain outcome. In this picture on the left, you will find that there is a tree diagram that illustrates the first draw being blue or red ball, and then the second draw also a blue or red ball. So let's say if I want to find the probability of the outcome RB, that means that we select a red ball in the first draw and a blue ball in the second draw. How do we actually find out what is this probability? Okay, the answer is that we can multiply along the branches, but why is it that that works? Let us consider this simple example. A fair coin is being first tossed. Then a ball is drawn randomly from a bag that contains one blue ball, one red ball, and one green ball. The balls are identical except for their color. If you were to draw a tree diagram, it will look something like this, whereby in the first column, we will find that we have the heads and tails when the fair coin is being tossed. And then in the second column, we will look at the event whereby the balls are actually being drawn, whereby B represents blue, R represents red, and G represents green. So as mentioned earlier about the tree diagram that is being drawn, the first column represents the coin being tossed, where we are getting either a heads or a tails. And then in the second column, we are drawing a ball, either getting a blue ball, red ball, or green ball. The different outcomes that we can have in this probability experiment is either a heads blue, heads red, heads green, tail blue, tail red, or tail green. So let's say if I want to find the probability of getting a heads and drawing a blue ball, that means we're trying to find the probability of HB, which is over here. Notice that there's a total of 6 different outcomes in this sample space. So since there's only one favorable outcome, HB over here, that means that our probability should actually be 1 out of 6. Now let's take a look at the tree diagram. Along the tree diagram, heads blue, is actually along this branch over here, as circled in red. If you look at the probability found on the branches, we find that if I take half times 1/3, I'm also going to be getting 1 over 6. Is this purely a coincidence, or is there actually a logic behind it? So that is what we want to explore in this video itself. So in this part, we are going to be looking at why does multiplying along the branches give us the desired probability. Earlier on, we noticed that the probability of the outcome heads blue is going to be 1 over 6, which coincidentally or not is actually equals to half times 1/3. So we are going to understand why is it that this happens and why is it that this works. And more importantly, does it extend to everything that we know for all probability experiments. Now we know that total probability for any experiment is always going to reach a maximum of 1. Our probability values can never be more than 1, neither can it be lesser than 0. So a total probability, which is actually equals to 1, will be represented by this rectangle for this probability experiment. So everything, covered by this tree diagram is actually represented via this rectangle. The shape doesn't really matter. I just find rectangles easier to divide proportionally. You could always use any other shape, to represent the idea. Alright, so in our probability experiment, the first thing that we did was to toss a coin, to get heads or tails, and that is actually probability of half each. So in this rectangle, what I'm going to do is to divide it into 2 equal parts. I highlighted in red and yellow. Heads and tails, half each. Alright, so what we're seeing over here is that, the probability of this section over here of getting heads is actually half. Likewise at the bottom, the probability of getting tails is actually half. Now I'm going to divide this rectangle into 3 equal parts because in the next part of our probability experiment, we were looking at drawing either a blue ball, red ball, or green ball, and that is a probability of 1/3 each. So dividing the rectangle into 3 equal parts, I'm going to achieve this. So I see 3 equal parts over here. And each part itself is representing blue, red, and green, having a probability of 1/3. Okay, so essentially, if you're looking at the full picture now, I actually have 6 smaller rectangles, okay, each representing the different outcomes. So let's say if I were to be looking at this rectangle itself, oops, I'm sorry. Let's say we're looking at this rectangle itself, okay, I call it rectangle number 1. Okay, I'm looking at the outcome heads blue. Okay, so for the outcome heads blue itself, right? Originally, we were seeing it as half. Okay, so heads blue was over here. Okay, so it is a part of the half, right? Okay, how many parts out of the half? It is actually 1/3 part of the half, because I further divide it into 3 equal parts. So that means that I'm taking 1/3 of the half. Therefore, 1/3 times half will give us the probability that we want. This definitely applies to every other smaller rectangles that we see over here. Okay, and I hope that this helps you to understand why is it that multiplying along the branches gives us the desired probability. Right? So we have seen that to find out what is the probability of a certain outcome, in our earlier case we were looking at the outcome of heads blue. Okay, we can just simply multiply the probability found along the branches, which in this case is half times 1/3. Now there is a name for this probability. Okay, so firstly, what we call this probability over here, this half, okay, we just simply call it the probability of achieving the heads. Okay, and that is equals to half. Now what I want you to pay attention to is the name of this probability over here, this 1/3. Okay, this 1/3 is called the probability of the ball drawn is blue. I'm sorry for this typo error over here. Okay, given that the coin toss is heads. So notice that the phrasing is rather lengthy. There is this point about given that the coin toss is heads. What it's trying to say is that they're asking us to ignore the fact that the coin toss is actually heads. They only want that probability, okay, of it to be blue. So they want you to actually, in fact, follow this trajectory, okay, to identify this probability. So the probability of the ball drawn is blue, given that coin toss is heads, is actually the value of 1/3. To help you reinforce the idea, okay, what if I want to find out what is the probability of the ball drawn, pardon me for my bad handwriting, is green, given that coin toss is tails. Okay, so where and how do we find out what is this probability? We know that it is given that coin toss is tails. That means that we have to look at this trajectory over here. Okay, and then ball drawn is green. That means that we are looking at this section, and that is actually equals to 1/3. Okay, so probability of ball drawn is green, given that coin toss is tails, okay, would actually be this 1/3 value over here. Alright, so therefore, okay, to conclude, okay, this entire video, the probability of heads blue is actually 1/6, and that is achieved by multiplying along the branches for the outcome that we want.